Ever pondered about the mysteries of dimensions beyond our perception? Ever wondered about the enigma that is the universe? Today we dive into a theory that dares to explore these questions, the Kaluza-Klein theory. A classical unified field theory, it daringly intertwines gravitation and electromagnetism, all by introducing a fifth dimension beyond the conventional four dimensions of space and time. The development of this theory came in waves, with the first tide brought on by Theodore Kaluza in the early 20th century. In 1919, Kaluza proposed the original hypothesis, a purely classical extension of general relativity to 5 dimensions. His theory involved a 5-dimensional metric tensor with 15 components. 10 of these components represented the 4-dimensional spacetime metric, 4 components stood for the electromagnetic vector potential, and 1 component symbolized an unidentified scalar field, sometimes called the radion or the dilaton. Kaluza's equations yielded the 4-dimensional Einstein field equations, the Maxwell equations for the electromagnetic field, and an equation for the scalar field. To keep the mathematics from becoming overwhelmingly complex, Kaluza introduced the cylinder condition hypothesis, stating that no component of the 5-dimensional metric depends on the 5th dimension. The second wave came in the form of Oscar Klein's quantum interpretation in 1926. Klein brought the theory in line with the then recent discoveries of Heisenberg and Schrödinger. He hypothesized that the 5th dimension was curled up and microscopic, explaining Kaluza's cylinder condition. Klein suggested a circular geometry for the extra 5th dimension, with an incredibly small radius of the order of 23 times the Planck length, which is about 10 to the negative 33rd centimeters. Klein's contribution also included providing a properly normalized 5-dimensional metric. The final wave washed ashore in the 1940s with the completion of the classical theory by 3 independent research groups. They obtained the full field equations, including the scalar field, giving the Kaluza-Klein theory its final form. These groups included Thierry, working in France, Jordan, Ludwig and Müller in Germany, with critical input from Pauli and Fierz, and Scherer, working alone in Switzerland. So, there you have it, the development of the Kaluza-Klein theory, a journey that spanned decades and challenged the conventional understanding of dimensions. This theory dared to explore the mysteries of the universe, from the familiar 4 dimensions of space and time to a proposed 5th dimension. It combined the forces of gravitation and electromagnetism into a unified field theory, all while navigating the complexities of classical and quantum interpretations. From Kaluza's original hypothesis to Klein's quantum interpretation, and finally, the completion of the classical theory in the 1940s, the Kaluza-Klein theory remains a fascinating exploration of the dimensions beyond our perception.